I'm Joe Nolan. I'm the Vice President of Research for the Insurance Institute for Highway Safety. Frontal crashes are the most common type of crash that results in serious injury or death. Most of these crashes don't happen head-on where both vehicles are lined up. Rather, there's some amount of offset between the vehicles. The Institute's two frontal tests help you evaluate how well your vehicle might protect you in these types of crashes. In our moderate overlap frontal crash, a vehicle strikes this barrier at 40 miles an hour with 40% of the vehicle's front end width lining up with the barrier. This section of the barrier is made out of aluminum honeycomb that crushes like a real car would in a crash, and it's mounted to a larger barrier that's 320,000 pounds of steel and reinforced concrete. The second type of crash we call a small overlap crash. We accelerate a car down a track into this barrier at 40 miles an hour with only 25% of the front end of the car lined up with the edge of the barrier. This barrier is rigid, it's got a radius of 150 millimeters, that's about 6 inches, and that represents what happens when you hit another car in that small overlap, or you hit a tree or a pole or a post. We evaluate frontal crashes using 3 criteria. The first is how well the safety cage held up and protected the occupant from intrusion and injuries related to the forces of the crash. The second is measures from the dummy itself on the risk of injury in the crash. And then the third criteria is how will the restraint system, seatbelts and airbags, work to protect the occupant and keep the occupant away from any injurious impacts.
My name is Chris Sherwood, Senior Research Engineer at the Insurance Institute for Highway Safety. When we assess vehicle structural performance in frontal crash tests, we look at the amount of deformation or intrusion at a series of locations inside the occupant compartment. It's important for vehicles to minimize this deformation because as those structures come back toward the occupant, it's much more likely to cause injury. In this vehicle, the structure had poor performance. The wheel was pushed rearward into the lower part of the occupant compartment, causing a lot of intrusion into the footwell. The pillar, the instrument panel, and the steering wheel were also pushed rearward and inboard, and this increases injury risk to the occupant.
Hi, my name's Becky Miller. I'm a crash test coordinator and research engineer. What we have here is a display dummy that's cut away so you can see all of the different sensors and components in the dummy. We have sensors in the head and the neck, the chest, the upper leg, the lower leg, and the foot, which all measure risk of injury. Today, in moderate overlap crashes, dummy injury measures tend to be low for all body regions. This is because vehicles are designed for this crash mode and restraint systems properly protect occupants from injury. In small overlap crashes, some vehicles do a good job of protecting the occupant inside. In other vehicles, we may see high risk of injury. This is because many manufacturers have not designed for this crash mode yet.